sequence is a function whose domain is the set of positive
Okay,
integers.
function whose domain is,
The set of positive
there you
integers.
go. And guys, I'm gonna represent that like this. Z is integers with a superscript of a positive sign. In other words, I'm talking about these types of numbers only for the domain of this function that they call a sequence. A function whose domain is a set of positive integers. Now, the way I started, and I may have brought some notes in here and also a handout, I did this. It looks like I did this. And that is, looks something like this. If I gave a class this, to get started, let's make it infinite. That to me, as a student, you just walked in and heard the word sequence to begin with, you said, Professor, I know what a sequence looks like. A sequence of numbers, a sequence of something. It's a sequence. There's a few numbers in there called terms. It's just a sequence. They want us to make sure, though, that if that is a sequence, which it is, can I rewrite it as a function, it's called f of x, that would give me those numbers, and my domain here is, and must be, one of these numbers. So the domain is a set of positive integers we use only. Now guys, if I look at 1, 3, 5, 7, most students would recognize the others are pattern here, Professor. They differ by 2. There's no one thing they might know if I say f of x in terms of x, what might you use for a formula that might give me those numbers I have listed. And you've got to start out with, when you finally give the formula to me, I got to replace x by 1, and I had better get 1. When you give that formula to me, replace x by 2, you got to get 3. Replace x by 3, you got to get 5. Does anyone think they know what that formula would look like? F of x equals, and I'll try it and see if it will give me 1, 3, 5, 7, infinite goes on like that, 9, 11, odd numbers. You have an idea what the function might look like. And then I'll start replacing and checking, see if I get those numbers. What do you think, guys? Now, I'm going to move on to this fairly quickly, though. This was not too bad to look at to come up with a formula. Okay, now I saw a few hands going up. So, Matthew, what do you have in mind?
Just like x squared n plus 3.
No, just in plain x, just x.
X plus 2.
I see why you're saying x plus 2. Hang on now. I see exactly why you said that. Now, if she's correct, we're saying now, by definition, you've got to let your x be 1 first. If you go back and replace x by 1, in here you get 3. Was 3 my first term? No. I see why you said plus 2 though. I need something that when I replace x by 1, you're going to get 1. Replace x by 2, you're going to get 3. X by 3, you're going to get 5. What does that function formula look like? Or does it exist? Olivia?
2x minus 1.
Now if you say 2x minus 1, we'll test it. If I replace x by 1, which I required, in her formula, you'll get 1. That's what the answer. If I replace x by 2 in her formula, 2 times 2 is 4 minus 1, short enough you get 3. Third term should be at 5, let's see if it is. Replace x by 3, 2 times 3 is 6, 6 minus 1 gives me a 5. It looks like it's working. Now, the benefit here is, if you come up with the correct formula, David, I could ask you to find the 100th term. You say, Professor, no problem. Replace in the formula 100. You get 200, subtract 1, what is that, 199? And 199 definitely would be in this sequence of numbers. So she's giving me a formula that's going to give me all those numbers you see listed, all the odd numbers, 2x minus 1. It's coming up with the formula, though. That may slow you down. And then, with this positive integers, by restriction, by the definition, I've got to let the domain be only these numbers. And it works out there. Now we'll try another one with you. We're going to just sort of look at it and say, Professor, let me sort of guess at this one. Let's see if I brought another one in before I turn to the handout. It looks like, let's see if it does. Should look like this. Oh, here it is. Part A, let's call this example number 1. Example number 2, let me put it over here. Suppose my sequence now looks like this. Just to get the hang of this. It's a sequence of 1, 4, 9, 16, and goes on forever. And I'd like to come up with a formula. I'm calling it a function right now. Does anyone have an idea of what functions could I list that when I list or substitute 1 in it, I get 1. When I substitute 2 in it, I get 4. I substitute 3 in it, I get 9. What's that formula look like? Go for it. X squared. If I replace x by 1, I get 1. X by 2, I get 4. X by 3, I get 9. So forth and so on. So now they ask you what's the value of the 15th term in this sequence? With his help, you put a 15 in here. 15 squared is 225. Let's look at this, trying to come up with a formula on this. So guys, in essence, that's what a sequence is all about. Now notice chapter 11, all textbooks do. They finally changed their notation. Rather than using f of x, they do this. They like to use an a. A subscript n is equal to n squared. In essence, we're saying the same thing. Rather than using the f of x notation, I like to use a subscript n. I'll show you what that subscript n here shortly looks like. Here, same thing. Rather than f of x notation, they love to, for a sequence, use this. A subscript n is equal to 2n minus 1. Like that. And I could give more examples where we sit here and stare at it, trying to come up with a formula. But in essence, you're going to have numbers listed in a sequence, and then we ask you to find a particular term. And you can't find it unless you find the formula for it first. And that's merely standing there and looking at it through observation. Guys, in essence, that's what we're doing here. But with all that said, I'm going to move into part 2. Now, I give you a handout. Sarah, let me see yours just a second. Beautiful. If the formula is listed for you, I think on the handout here, I actually gave the formula to you for these. You don't have to stare at it and try to come up with a formula. The first one looks like, Sarah, read this to me. It's a subscript n, was it? Equals what?
A subscript n equals n minus 1 over n.
Hang on. Now that's beautiful if I give that to you on the final. And then I ask you, did I ask you to write a few terms out? How many terms did I ask you to write?
6.
6 terms? Okay, so here, she says, Professor, the formula's been given to me. 1, 2, 3, 4, 5, 6. They want you to write out the first 6 terms. No problem. This is identified as A subscript 1. 1, first term. Formula, replace n by 1 over there, and you have that, which merely gives you a 0. If you want the second term, that's why they like that A subscript 2 here in this case, that's the second term. Go up to my formula she gave me, replace n by 2. I make no mistake. Looks like it's 1/2. A subscript 3, go up to my formula, 3 subtract 1 over 3, looks like it's 2/3. I'm doing this real quickly. A subscript 4, I'm going to list the 6 that she wants here, put a 4 in there. It's going to be 4 subtract 1 over 4, well, that's 3 over 4. And in fact, you might even see a pattern now. You can just go ahead and write the last 2 terms without relying upon the formula. Okay? Guys, does anyone see what the next term would be without me going through all this? 4/5, 4 over 5. And the last one would be
5/6.
5 over 6. That's what we're doing. We're listing sequences. I love it when they give the formula to you. Now, Sarah, tell me, that's the first one. Tell me another one I tried there where I gave the formula to you.
A
Subscript n,
equals 3 to the n.
3 raised to the n
Over n.
over n. Now, I think on the handout it says write out the first 6. I'm just write the first 3 for the sake of time. The first 3, no problem. Guys, a subscript 1, if I do it correctly, replace n by 1. You get 3 raised to the 1 over 1. Too quickly there. Looks like I'll end up with a 3. A subscript 2, put a 2 in there, it's going to be 3 raised to the second over 2. What's that, 9 over 2? And since I'm going to just write the first 3 for the sake of time here, a subscript 3 would be 3 cubed over 3, what is that, 27 over 3? Is that 9? Did it quickly? That's true? Mm-hmm. And those are the first 3 terms. How could you go wrong? If I give the formula to you. You can't go wrong. I don't think. Okay, now, did I have one more? I doubt if I do it, but did I have one more there just for an example?
Yeah.
Read it to me, let's see how difficult it may look.
-1 raised to -1 times n over 2n minus 1.
Hang on then, hang on. Let's call this number 1, here's 2, number 3. Sarah, do me a favor, read that to me again. A subscript n is equal to a -1, wasn't it?
-1 raised to n minus 1.
Oh, n minus 1, okay.
And then there's a parentheses n over 2n minus 1.
Okay, guys, let's write those, just the first 3 terms. No matter how it looks, if that formula is given, just follow the formula. First term, a subscript 1. Let's replace n by 1. That's what we'll end up with. I'll do it quickly. I think it's going to be, what's that, 1 down here also. So all together, looks like it's going to be -1 raised to the 0 times 1. Now, if I did that quickly, I did it real quickly, I think it's okay. What's anything raised to the 0 to begin with? 1. So actually it says 1 times 1, so you're going to end up with that first term to be 1. With what she gave me, let's write the second term. Second term, replace n by 2 in this so-called sequence. And guys, replacing by 2 will give me, I think on the bottom there, 3 when I do the arithmetic. Now this says -1 raised to the 1 times 2/3, and I think that gives me, when I do the calculation, what's that, -2/3? I think. So that's my second term, if there is no mistake. Third term, just for the sake of practice, put a 3 in there, so it's -1. When I put a 3 in there, guys, you'll end up with a 2 there for the exponent. And of course, we'll end up with 3 over, looks like maybe a 5 when I do that. And of course, -1 squared is 1. No mistake here, it should be 3/5. And there's my third term. Let me list it like this so you can see it. 1 comma, -2/3, 3/5. Those will be the first 3 terms. Now, we throw in one that I did not place on the handout for a reason here. Number 4, a subscript n is equal to, just go ahead and do it now. And looks like with exclamation mark in mathematics for chapter 11. Some students may have seen that mark and what it means in math. In exclamation, and it was given a name, if you have never seen it before, and I'll show you how to use it. First, if I see it written like that, it's known as, for a vocabulary word, it's a factorial.
Oh, yeah.
In factorial, in case you've seen it. Now what it means though is this. They want you, when we finally do it, to start out with whatever n is, and then decrease by 1 in a long product until you reach 1. And what that the result will be, that's known as the factorial of that number. Now here I go for an example. If 5 factorial, you're staring at it, you say, Professor, what is 5 factorial? If I follow the rule here, it says start out with 5. Next part says n minus 1, next factor, that's 4. Next factor says n subtract 2, 5 subtract 2 is a 3. Then you're going to end up with a 2, and eventually you end up with a 1, of course that's where you stop. So that's where 5 factorial looks easily written out. Multiply all those numbers together. Guys, I think just staring at it and looking at it, is it 120? I think. Or more. 60, no, that's 20 times 3 is 60, it is 120. And that's n factorial. Now, what they do, just in case David, we run into this a little bit later on in this chapter, close down. If, now that's going to look strange, by definition, Lauren was the definition, if you have 0 factorial, they want you to accept that as, without argument, 1. If you see 1 factorial, no argument, 1. So those two look a little strange here. 0 factorial looks like it should be a 0. The 0 factorial is to be considered for math 1. And then 1 factorial makes more sense. It should be 1. I did 5 factorial, got 120. Now, my formula is this. Now, let's write out maybe the first 3 terms of this. Sarah, you help me out here. I'd like the help. Let's write the first 3. This one is a subscript 1. That's my first term in the sequence. Go back to replace n by 1. So you got 1 factorial. No problem. That's got to be a 1. The second term of those 3 terms, go back and replace by 2. Got 2 factorial. And you write that out, what? 2 times 1, which is 2. If I ask you for the third, a subscript 3, that's 3 factorial, they call it. And what value would that be if you multiply it out? It's going to be 3 times 2 times 1, which will give you a 6. And those are the first 3 terms of if it were n factorial. Okay? So guys, if the formula is given to you, you can't go wrong. You replace it always with 1 first, then 2, then 3, and follow the rule there, and tell me what they look like. Yes?
So we basically stop at the number that you gave us?
There you go. When you say stop at the number I give you, oh, if I ask you to write 3 terms, you're going to just write 3 terms. If I ask you to write 6, you're going to write 6 terms. I'm doing this 3 terms to save a little time here. Okay? Just write out terms in a sequence. Now, with that said, you said, Professor, this chapter's going to close down real fast. It's going to close down real fast. I have, and Sarah's going to help me. Oh, beautiful. All my notes here done. Sarah, on the handout, here it goes. Would you read part 2 for us before I move on?
A second way of defining the sequence is to assign a value to the first or first few terms and specify the nth term by a formula or equation that involves 1 or more of the terms preceding it. Such sequences are said to be defined recursively.
Stop right there. Now, if I do, and many times on the exam I will, sometimes I like to give the sequence in a recursive formula. That means I'll start you out with the first value. I usually tell you the first value. Sometimes I'll give you the first 2 values, and then ask you to find the others after that. So for an example, she just read that to me. Don't let me copy this down wrong, Sarah. The first example says list the first 5 terms of this given recursively defined sequence and tell the class on the side here what was A1 listed as.
A1 was listed as -2.
-2, and they'll put a comma, and now did they give us a formula after that?
Yeah.
Okay, here goes, guys, this is the difference. What's the formula?
The formula that was given was
A subscript n,
a subscript n equals n plus a subscript n minus 1.
okay? Now, watch carefully. Now, looks like, and how many terms did I ask to list? 6 or 7, or how many?
5.
5. I got 5 terms here. This is a sequence. 80.
Yeah.
We blocked out if I give it to you recursively. That means I've got to give you at least one of the terms. I give it to you as -2. So I give you partial credit to show me that. Now I've got to find this term. Basically, these terms. So here goes. A subscript 2 is missing. Here's the formula. A subscript 2, replacing the n by 2, would be 2 plus A subscript, look how strange this looks, 2 subtract 1, right here. Replacing the n by 2, look for the second term. This means 2 plus A subscript 1. Now do you understand why I gave you A subscript 1? If I give you A subscript 1, that says now 2 plus, what was A subscript 1 given to us as? -2, I can put that in. And finally end up with 0. That's the second term. That's called recursively doing it. Third term, Sophia, looks something like this. A subscript 3, if I want to find it, by this formula, n is 3 plus A subscript 3 subtract 1. It's going to be 3 plus A subscript 2. Look how this works. To finish it up, Sophia, tell me what would I do to finish this thing up?
3 plus negative, 3 plus 0.
Thank you. You go back to the answer you found earlier, and of course I'm going to end up with a 3, and you get a 3. Now, what's the issue here before I find the last 2? The issue is, if you missed, let's say, suppose I made a little minor mistake where the answer should have been 0 and I had a 1. Then that's going to throw this one off. That's going to throw the next one off. I'm going to find one more. I'll stop at A subscript 4. A subscript 4, if I use this formula, it's 4 plus A subscript 4 minus 1. Guys, that's 4 plus A subscript 3. That's 4 plus an A subscript 3, we're hoping is 3. And if all that's correct, my next term is 7, if I have no mistake myself for that term. See how it's working? And you can actually list all those terms in that sequence if I give it to you recursively, as described. Now, Sarah, big help tonight. I think that's what we have done there, right? Now, here's what they want us to end with in chapter 11. Now, we move into chapter math 7. And you know, by the way, I described math 7, calculus. You can start out with, I taught a class of maybe almost 200 in an auditorium one time. And by the time I posted my final grades, we were down to 35. Students just sign up for classes thinking, oh, I'm gonna come in and just take this, not do anything. Then all of a sudden, F, fail, fail, fail. They just want to enroll in the class. Don't let that happen. Put too much time in, too much effort, especially this class. Put too much time in, too much effort. Here's what they want you to do. And I can't believe when I say it's almost like closing down this. Guys, all that was part 2, I guess. Part 3. So now, do a good job here and show them, discuss with them. Now take those terms of that sequence and add them up. Get a sum. summation. Now, we have a special way in the higher math to represent that they want you to do that. They want you to sum up these terms. So guys, that would be like me going back here, I'm not gonna do it on this, add these up. Add the terms up and get a sum. Back there, add the terms up and get a sum. They love to use this symbol from the Greek alphabet, sigma, to represent now they want you to sum. They want you to sum up the terms of a sequence. Now, Sarah, I'm looking at the bottom of the handout there, if I'm looking at the right one here, and I have a couple of examples. I have one that's written like this. At the base of sigma, they like to use a K. They're asking you, please start with 1. At the top, please stop at 8. We'll start with 1, stop at 8. And inside here, they gave the sequence formula to me, really 2K in this one. Now, what on earth, with the discussion on sequence, do you think they are asking me to do here this time? List those 8 terms and sum them up. Easily done, and they're telling you where to start. Start with K is equal to 1. So guys, if I replace K by 1 in 2K, of course you get 2. Put a plus sign. You're adding this time. Put a 2 in there. 2 times 2 is 4. That's my second term. Third term. Fourth term. Fifth term. So let me leave out one here. Count and see. 1, 2, 3, 4, 5, 6, 7. I need one more. And those are my terms. Summation says take the terms down and add them up. And then I want a grand sum. They want you to add them up. You guys, do I have all that written correctly? The numbers? That they're written correctly? Are they?
What'd you say?
I put 1 here, got 2. Put a 2 here, I got 4. Put 3, 6, 4, 8, 5, 10, 6, 12, 7, 14, 8, 16. And they said to stop at 8. Okay, that's all I did. And then we just add them up. And guys stand here looking at this, I see 6, 12, 20, 30, 42, probably 56. I'm gonna take a guess, I think it's 72. Done. Can't go wrong. Sarah, did I have one more down there? Okay, this one says you're gonna start with, you're gonna start with 3. Put it right here. You're gonna start with 3 and go through what, 6? The 6 at the top, -1, raised to the K plus 1, times 2 raised to the K. Oh, we're gonna have fun on this final exam. We're gonna have fun. Did I have that written down correctly?
Yes.
Okay. Thank goodness it's short. Okay, decent. We'll write this out?
Yeah.
Okay.
Yeah, I did.
I've got to replace K by 3, they said first. If I replace K by 3, guys, this thing's gonna look like this. -1 raised to the 3 plus 1, 2 raised to the 3rd. Next number coming up, 4. Let's just start with 3, go up through 6. 4, I'll make it look like this. -1 raised to the 4 plus 1, 2 raised to the 4th. 3, 4, and I'm up to 5. Put a 5 in there. -1 raised to the 5 plus 1, 2 raised to the 5th. And finally, I reached the top, which is 6, and they said stop there. Put a 6 in there for K. -1 raised to the 6 plus 1, 2 raised to the 6. And that's the way the terms look written out. If I don't have a mistake in there somewhere, I'm on top of the board here. Do we agree, guys? Does it look like this written out? Everybody agrees, says yes.
How'd you know you have to go to 6?
Right here,
Okay.
staring at you. Down here tells you where to start.
Alright.
Now, if I go through the calculations, it's also left to be done now. Guys, that, -1 raised to the 4th is 1. So 2 cubed is 8. That's my first term. Second term, -1 raised to the 5th is negative, and I got 16. So it's a -16. Next term, -1 raised to the 6th, probably a 1, 2 to the 5th, 32. -1 raised to the 7th, gonna give you a negative. 2 to the 6th is -64. I think. Then go straight across, if I don't make a mistake here, add these up, I see a -24. Is it a -40? Someone do it?
Negative.
Is it -40? I think it's -40. Yeah. And there's your sum. Now, Sarah, remind me, is that the end of that page?
Yeah.
Okay, flip it over. Flip the page over and see if there's something on the back there. More than likely there is. Now, whew, here's the way we're gonna sort of close down. If I look at the very first one, erase the sigma summation. Hayden, I'm going to continue this summation. Tell me what the next one was. It's on the back. Summation, then what's the sum up? What? Was it k is equal to 1? The first one on the back of the page?
K equals 1.
Yeah.
1, yeah.
What? And it says stop at
100.
100. And k. Now watch carefully. David? If I do as I'm supposed to do, it says replace k by 1 first, no problem. Replace k by 2, by 3, and it continues like this until I reach 100. Now, I guarantee you, if I place that on the final exam Monday, some of my students will be here 4 hours, 5 hours. Trying to add up 1 plus 2, okay, so that's 3. Plus 3, 6, professor. Plus 4, 10, professor. They want you to continue and add all the way up, all the way to 100, and get a grand sum, grand total. Now, the reason I brought this in, a little short story. Famous mathematician. I sort of wish sometimes schools would offer a history of math. Sometimes if they offer a history of math, take it, because it'd be interesting to see. They give the life of mathematicians, of how they fell in love with mathematics and so forth. This one, Mr. Gauss, and also he's done physics also. He did this. The story goes that he was 7 years old, based on what I remember from the history. He was 7 years old and was identified by his peers, older people in the mathematics, who had the experience, the older mathematicians. They saw this kid and said, wow, just by observation, this kid's out there, this kid's out here, the others are here. Not had students like that. One or two or three or four, way out here. And all of a sudden, I gotta look back here, and then I gotta go back here. And sometimes that happens. And Gauss was one of those. And they say, wow, we gotta give this kid, a tutor, someone to work with him. So they got one of the older mathematicians, if I got the name, you recognize the name probably, to work with this kid, Gauss, 7 years old. And they say the first question the older mathematician asked the kid was to sum up the first 100 positive integers. 1 plus 2 plus 3 plus 4, so forth and so on. And they say within seconds he had his hand up. 7 years old. Had his hand up. And so the older mathematician thought, well, this kid has a question. He didn't have a question. He had the answer. They say within seconds. As soon as the question was given to him, he knew the answer. Now what he did, and some students may have seen this before, some students may know the little technique this kid used. He said, wait now, hold on. Can you imagine 7 years old? Think about this. I have been asked to do this. And for me, let me identify this as the sum. Let me choose S for sum. That's what I've been asked to do. In his clever way, he says, wait now, should I be able to get the same answer if I add it backwards? Should that give me the same answer? Of course it would. Then when he noticed, when he lined them up, hold on. The way he has these paired up, all those pairs all the way across one, I think they add up to together, is that like 101? So he said, hey, wait now, they add up to 101. How many of these do I have? I have 100. But he had to modify this a little bit. What do you think he did as a 7-year-old kid to modify it? Because he's not quite finished. His reasoning's perfect, but he did this, though. He made it work. What should I do to modify it?
Divided by 2.
He's got to divide by 2 because he's actually got 2 sums here the way he's doing it. So he said, hold on now, to modify this, divide by 2. Do a little arithmetic. I think it came out to be 5,050. 101 times 50. Now, who on earth would sit there and look at that at 7 years old and even think like that? And then he became this great mathematician in his life. Who on earth would do that? Some students do that. And I've been blessed to have a few students who have been like that. The students are out there. They see things a little differently. He saw this so differently. I don't know whether the mathematician who was working with him expected that or not, but that's what he has. Now, what that tells us in these summations, I think, Sarah, you're going to help me out here. Did I now give a list of some formulas that may help us to sum up sigma, some of these, and I'll actually add them up directly like I've been doing? Was there some formulas listed there under summation formulas?
Yeah, we have 5.
Okay, about 5 of those. Now, hang on, I'm gonna list, you got the 5 right there. I don't have to list them to save some time here. So guys, what's gonna happen, I'm sure how to use them. Now we'll go very, 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 very good about this. Okay, the very first, I got the first example, guys. Mr. Gauss says the answer here is 5,050. This one's done. That was the first one. Sarah, tell me what the next summation was after that one.
The next problem.
Yeah, next one, sigma,
It's gonna be 26.
up through 26?
Yeah.
Okay.
And then parentheses 3k minus 7.
3K, how much?
Minus 7.
Minus 7. Now, Aiden, if you solve just that one problem there on the test, without Ramsey's work tonight, that would be the test. That would take some of us an hour. At this point, you say, well, I guess, Professor, I can at least do this for you, Professor. David, I can write a few terms out. If I replace k by 1, I say, oh, it's roughly start with k to be a 1. So I put a k equal to 1, that's 3, subtract 7. My first term is a negative 4. If I replace k by 2, I get 6 subtract 7. I think it's negative 1. And so forth and so on until I reach the end, and I think she's telling me we're supposed to stop at 26. So I put a 26 in there. 3 times 26 is 78.
Yeah.
Subtract 7, is that 71? Is that true, guys? So I'd rather a few of the terms out for you. I didn't write them all out for you. They're saying now add them all up and get a grand sum here. Good luck.
Can you do the same thing?
You. Sometimes you can, sometimes you can't. Samantha, brilliant. She says, Professor, can I do what the 7-year-old kid did, Gauss? line them up backwards. Now if I do, hang on a second here, if I put a 71 here, and guys, what would the other term down here be? I've got all these, do they differ by 3?
-1.
Okay, so could I put that here, then the next one here, like he did on his problem, and maybe they line up perfectly for me? That's a possibility. In fact, I'm gonna do that, but we'll show you something else that you could be doing here. Now, Sarah, let's look at the formulas. These are the most important parts of the formulas. Close this down, guys. If they ask you to sum up, and I'm gonna do it by formulas here shortly. These are summation formulas. First one I want to look at is this one. If you're asked to sum up, let's say k is equal to 1 through n of a constant, just a number inside there. Find that sum right quickly, multiply c times n. We'll call that my first formula. I'll show you how these formulas work here shortly. If I'm asked to sum up k is equal to 1 through n of k, that's n times n plus 1 over 2. Because I have all these on the handout for you. And the last one that we'll look at right now is if you're asked to sum up 1 through n, k squared, n times n plus 1 times 2n plus 1 all over 6. We're about to close this down. About to close your course down. Now, you open up the math 2 textbook, go to the formulas. They're listed for you in the textbook. And you know how formulas are, David? Sometimes you see them in the textbook, and the textbook shows not where they came from. They say, this is a formula. Memorize it. So make sure I have all this copied down correctly. Now, we'll go up to my problem and see what I can do here on this first one. And we'll rewrite it. Marco, here goes. We'll rewrite the problem. You're allowed to put that 3 out front. This is the number. You may move it out front, out of the way. And that would leave me this in the first term to worry about. That's my first term rewritten. This says subtract. My next summation is this, going from 1 through 26, merely a 7. I split them up. Now, can I use the formulas? The first one says, if you want to add these up by formula and not actually add them up directly, it says the formula is, right here it is. This is the summation of k, they call it. N times n plus 1 over 2 will get you to the result quickly. We'll get to you, the sum to you quickly without you writing all those numbers out. So guys, in this case, that would be 26 times 27 all over 2. So all that, do that correctly. I'll come back to that. Now subtract from that. Now it says on the end, summation of 7, 1 through 26. You know what that means? It means 7 plus 7 plus 7 plus 7 plus 7, 26 times. You want to do it quickly? Here's my formula. And C is a constant. Now I've got 7 is a constant. You just need to multiply these two together, and I'll get the sum to you quickly. Multiply these two together. N times C, in my case, that's 26 times 7. But you gotta know your formulas. Now going back and finish it up, we may not get the complete answer here. Cancel, you could cancel this, and this get 13. Guys, to save me a little time here, 13 times 27, you have to do that arithmetic. Then subtract 7 times 26, you have to do the arithmetic. And then after you do all that arithmetic, David, you'll finally get that answer that we're looking for. But you gotta know your formulas.
Do you mind explaining
Okay, where am I? Right here? Yeah, if I have a constant here, in my case, I have 7. So the formula says if I have a constant, then you C for a constant. To find the sum real quickly without adding them up, let's multiply these two together. And that's what I did here. That's right, guys? I know what it is, we're tired because we went through all this tonight, and all the other stuff on your mind right now. Just getting ready for the test. Okay, the next one, I'll let you guys finish it up, just merely a repetition there. Sarah, now to close this down. The next one was another summation, I think.
There's,
Try to find it.
there's 2 problems on the bottom.
At the bottom, that's where I'm going right now. Guys, I'm gonna do one for you. Here goes, I'm gonna do that. First one, summation. We'll call it quits on all this. K is equal to 1 through 14. K squared, subtract 7K plus 2. Now, that's going to close it down to this. Let's write out a few of the terms here. Let's just see what a few of the terms look like. And then I'm going to use the formulas though to find the sum. Guys, if I start with 1, and they said start with 1. I'll replace all those K's by 1, do the math. I'm standing here and looking at it. 1 subtract 7, negative 6 plus 2, I think it's negative 4. My first term. Now replace K by 2. I'm not going to write all 14, so let's go through 14. Replace K by 2, I see 4 subtract 14, that's a negative 10, I think. And negative 10 plus 2 gives me a negative 8. Try one more. Replace K by 3, I see 9 subtract 21. 9 subtract 21 is what, negative 12? And negative 12 plus 2 gives me a negative 10. Sarah, we're supposed to do that all the way to the end, and I know the end's a nightmare, because we're supposed to put a 14 in there. 14 squared, subtract 7 times 14 plus 2, which you could do, and find what that last term looks like. I don't have it here, I'll just put a little box there. You can find that, we'll take a little time. We're after this though. We're after what will they all add up to? That's what I'm after. I'm after the sum. Now let's split this thing up. David, here goes. First, summation from 1 through 14 of K squared. Now we set up for you guys. Subtract. I'm on the second term. Let's put that constant of 7 out front. Makes it look nice. That would be for the sigma part, summation part. 1 through 14 of K. On the end is a nice constant. 1 through 14 of 2. There it is split up. Now here's formulas. This says for K squared, if I had the formula written down correctly, gotta use this. Here's the formula for it, K squared. And guys, in my case, that would be, it says n is 14. 14, n plus 1, 15. This is not that bad if you look at it. 2 times 14, 28 plus 1, 29, I guess. And all that's over 6. That one could be now calculated. If I replace by 14 into this formula. Lisa, is that good? Next one has a 7 out front. And Lisa, the next one says now find from 1 through 14 of K without actually listing all the numbers and adding them up. There's the formula. So n times n plus 1, in this case that's 14 times 15 over 2. That's this one. Finally, on the end, which I think is the easiest one, that's this one. Which is merely a constant. And to do it quickly, by the sum, multiply these two together, n times c, 2 times 14. Now all the sigma notation's gone. If they have the formulas and written it out. Now, all you would have to do as a student is to crunch out, add them up, and see what that grand total is, guys. I'm not gonna do it for you. I know it would take a little time if you saw something like this. You have to crunch out this arithmetic, add those up, and that should be the grand sum of all those numbers. With the help of formulas. Wow, wow, wow. Now, take some questions. Here we go. Chapter 11, sequences, then all of a sudden they actually start adding up the terms.